Hey there, math scholars. So this is our first homework video of the year. Usually what happens is I do the odds and you do them with me. You write exactly what I write down on the paper. Then you do the evens because they're pretty similar to the odds. And if you have questions, then you call me. Again, write down exactly what I write down, show my work, because I'm trying to help you when it comes to the evens, kind of show the proper work. Sometimes I may even tell you to like write something or like put a star on your paper to prove to me that you watched the video, something like that. So yes, you should have a star on your paper right now. First, rewrite each expression vertically, then line up the decimals and find the sum. There's actually some subtraction problems on here, so we're also going to say slash difference. Yes, you need to write that down. So 6.3 minus 0.669. So start all the way over here and say 6.3 minus 0.669. So when you subtract or add decimals, you line them up by decimal, and that's exactly what we did. In any empty spaces, you can fill in with zeros, just like I'm doing. All right? So now let's subtract. Well, I can't do 0 minus 9, so I got to go over here and borrow. That becomes a 2. This becomes a 10. Borrow from that. That becomes a 9, and this becomes a 10. So 10 minus 9 is 1. 9 minus 6 is 3. Can't do 2 minus 6, so I borrow again. This becomes a 5. This becomes a 12. 12 minus 6 is 6. Put your decimal down. 5 minus 0 is 5. So our answer should be A, 5.631. If you get an answer that's not one of these answer choices, it's probably a good thing. It's probably a reason, probably an indicator that you did something wrong. Number 3. So we'll say 0.5 plus this time 6.77. Draw your line. Okay, we have everything nice and lined up. Empty spot, so I'll add a 0. I'll do 0 plus 7 is 7. 5 plus 7 is 12. Put down your 2, carry your 1. 1 plus 0 plus 6 is 7. Don't forget to put your decimal point down. So our answer should be B, 7.27. And lastly, on this section, number 5. So 4 minus 1.1. So I'll do 4 minus 1.1. I have everything lined up. I should add a decimal for 4 and then an empty space, so 0. So I can't do that, so I have to borrow. So 10 minus 1 is 9. 3 minus 1 is 2. Put my decimal down, 2.9 D. First section, all done. All right, for 7 through 10, we're going to be doing multiplication. So first write each expression vertically, then find the product. That means the answer to a multiplication problem. Be sure to swoop your decimals at the end, and I will show you exactly what I mean by that. So we'll say 5.5 times 2.7. First thing you should do is say, hey, I have one decimal in this right here, right there, that 5, and I have one number behind my decimal in this number, so that's 7. So in the end, I should have 2 decimal places. So let's multiply. So 7 times 5 is 35, carry your 3. 7 times 5 is 35, but it's 38. Now you're going to run out of space here, and I apologize, but this is as much graph paper I could fit on here. So 35, so 38. Lay an egg, and then multiply. 2 times 5 is 0. Carry your 1. Sorry, 2 times 5 is 10, so carry your 1. Put your 0 down. 2 times 5 again is 10, plus 1 is 11. So again, you kind of ran out of space there, and I apologize, but that's how it goes. So 5, 8, 4, and 1. Now that's not my answer. I should have 2 decimal places here. So I go once, swoop twice. Start at the end, swoop twice. And I have 14.85. All right. I'm going to start kind of over here this time, see if I end up with more space. So 1.51 times 0.2. Recognize that you have 2 decimal places here, 1 decimal place here. That means I should have 3 decimals in my answer. So let's go ahead and do it. 2 times 1 is 2. 2 times 5 is 10. Put a 0, carry your 1. 2 times 1 is 2, plus 1 is 3. My answer is not 302 because I have 2 decimals. 5 and the 1 are the numbers behind the decimal, and 1 decimal. The 2 is the only number behind that decimal. I should have 3 numbers behind my decimal here, so I'll swoop 3 times. Once, twice, 3 times. And that's my answer, 0.302A. Let's go over to the back side. It says, use the picture to find the difference in the average income. Difference means subtract, right? Oops, sorry about that. That happens sometimes. the difference, so subtraction, in the average income and the lifetime income for a high school graduate and a college graduate. This graph is trying to depict the importance of not only graduating high school but also going to college and trying to graduate. So let's do average income first. So we'll look for average income. So there's my high school average income, and here's my college average income right here. So what's the difference? So we'll do 53800 minus, we'll try and line up our numbers nice and straight, even though there's no graph paper, to 7700, and we will subtract. So when we subtract, we get 0, 0, 1. We have to borrow. 13 minus 8 is 5. 4 minus 2. So there's a difference if you graduate high school and if you graduate college. College graduates make $25,000 more on average income than high school graduates. That's why we emphasize the importance of trying to go to college. So not only can you take care of yourself, you can take care of your family, and like I said before, you can make the world a better place. You're going to do the same thing over here, but this time for the lifetime income. All right, 13 through 15, this section we have some rounding. So I want you to round to this place. This is our big boss, little boss, if you remember from 5th grade. So if it's 5 or more, you round up. And if it's 4 or less, you round down. So 7.96 means I'm going to be rounding up on that. So 7.9, the next number I go to is 10, which I can't. So that turns into a 0 and the carry the 1 there. So it rounds up to 8, 8.0. If I wanted to round to the nearest tenths, it gets kicked up to another whole number. So here it wants you to round to the nearest hundred thousands. So you look at the place value in front of it. That's the 7. The 7 is 5 or higher, so this gets rounded up to 400,000. Everything behind it becomes zeros. All right, 17 through 20, we're trying to compare fractions. Basically, what you need to know is if you have like denominators like you do here, it's pretty easy. You just look at the numerators and you say, all right, well, 2 is less than 3, and 3 is less than 5, right? But what happens down here when you don't have like denominators, or in problem 18 or in problem 20? None of them have like denominators. So the logic here is same denominator, just look at numerator, right? Yes, you need to write this down. Just look at numerator. Here, you got to ask yourself, okay, this is one more number away from being a whole. 11 over 11 would be a whole. This is 2 more numbers away from being a whole, and this is also 2 more numbers away from being a whole. Right? So there are a couple ways you can do this. You can either do the butterfly method, where you multiply 10 times 21 and you get 210, and you multiply 11 times 19, and even Mr. Mason is going to his multiplication chart right now, his reference sheet. He's looking, he's saying, all right, I have 11 and I do times 19. Okay, that gives me 209. And you say, all right, what's bigger, 210 or 209? Well, 210 is bigger. And this only had one more number to become a whole, so that means it's a bigger number in the first place. It's a bigger fraction because it's a whole number, right? Almost a whole number. You can do the same thing here. So this time it's 12 times 19 using my multiplication chart, 12 times 19. All right, so this is, we'll scratch this out and we'll put 228. And then 21 times 10 again is 210. So what's bigger? Well, this one's obviously bigger. So 228 is bigger, right? You eat the bigger number. So it says 19 over 21 is greater than 10 over 12. And okay, so they both this time have 2 numbers left, right? But because this one has a bigger denominator, these are smaller pieces of fraction. So this is closer to being a whole than this is. Even though they both only have 2 pieces left, this has a smaller numerator. So these are bigger. These are 2 bigger pieces that have to get filled in. If you imagine this as like a circle, right? And you had divided this up into 12 pieces. I'm going to do a really bad job of dividing this up into 12 pieces. Sorry. But it's like 10 of these were filled in, and these 2 big pieces were left. Whereas like you had this circle, and this was like 21 pieces. Like 21 pieces. Oh, so close, so close, so close. Like you would have just these 2 little slivers left or something like that, and that's why that's a bigger fraction. All right, so try and use the butterfly method. You can say butterfly, or you can say like pieces left as your logic in how you said they were greater or less than in numbers 18 and 20. Remember, this is due on Monday. Please call me if you have any questions. In case you're trying to find that sheet that has my number, but you can't find it, go ask your parent right now for the parent contact sheet that has my number on there. Thanks. Have a good night.